Alright, Unit 7, Day 11, we're going to solve logarithmic equations, and these are equations that have logarithms in them. We did exponential equations yesterday, and we used this property yesterday. We used a log to get rid of the base. Today we're going to go the other route. We're going to use a base to get rid of the log. And I don't know if it makes sense or not, but if I said, if I cover up this and I said b to what power equals x, okay, and let's say it's like c, so if I take b to the c power, that equals x, so whatever that power is, that's c. Now take b to that power, so if I took it to the c power, I get x, because you said b to what power equals x. Now take b to that power, you get x. So using a base can undo a logarithm. Now how that works is like here we've got log base 8 of x equals 3. So the base I want to use is 8. So what I'm going to do is I'm going to take 8 to this power and to this power. So these become exponents. So it'd be on this side it'd be 8 to the log base 8 of x power, and then on the other side I have 8 to the third power. Okay. And on this side, again, when the bases match, all that's left is x. So here I just have x, because this is saying 8 what power equals x. Now once you have that, take 8 to that power. Well, you'll get x. So this equals x, and then 8 to the third is 512, and that's your answer. The next one, here I got a logarithm. I got -7. That's not with the x. So just like yesterday, get it by itself. I need to get that logarithm by itself. So I'm going to add 7 to both sides first. So log base 9 of x would equal 2. Now the base I'm going to use is 9, because that'll get rid of log base 9. So I'm going to take 9 to this power, take 9 to that power. This would be 9 squared is 81. If you want to check yourself real quick, plug it back in. 9 to the what power equals 81, it'd be 2. 2 minus 7 is -5, so that's right. Next guy here, now this is in the logarithm, so 5x plus 2 is inside, so you don't need to get rid of it. Up here, that -7 was not inside the logarithm, so I got rid of it first. But down here, this is inside the logarithm, so I'm going to use a base of 2. I'm going to take 2 to this power, which would give me 5x plus 2. And then on the other side, I've got 2 to the 10th power, which would be 1024. So 5x plus 24, 5x plus 2 equals 1024. So subtract 2, I got 5x equals 1022 divided by 5, and for this one it's 204.4. Again, if you check this, you plug it in, it works. If I take it times 5, I'd get 1022, add 2 to it, it'd be 1024. 2 to the 10th power equals 1024. Now notice up here in directions, I didn't specify this. It says check for extraneous solutions. Basically what that means is the argument cannot be negative. So when you plug it in, when you get your x, you plug it back in, this cannot eventually equal a negative, because you can't have negatives in the argument. 2, you can't take 2 to any power and get a negative. And just like when we graph logarithms, we never went 0 or negative, so this can't equal 0 or a negative. So that's what we're looking for. Number 4, and this is my logarithm. I got this 4 hanging out here, so divide both sides by 4 first. So natural log of x equals 4. And again, here the base is e, so I'm going to take e to both of those powers. So on this side I'd have x left over. On the other side I have e to the 4th, which you could leave like that if you want. I don't have my calculator. I didn't figure out what e to the 4th is, but you could punch out in the calculator if you want and get the decimal answer if you need it. Number 5. Again, here's the logarithm, so get it by itself. So I'm going to add 15. So that's 27, and then divide by 3. So log base 2 of x would equal 9. And now the 2 is the base, so I'm going to take 2 to both powers here. So I got x And then 2 to the 9th is 512, and that's x by itself. Plug it back in, that argument is positive, so it's okay. So 512 works. Number 6, this is all part of the logarithm, the 6 is not. So if I divide both sides by 6, I got log base 8 of 7 minus 2x equals 2. 8 is the base that's going to get that logarithm out of there. So I got 7 minus 2x would equal 64. If I subtract 7, I get negative 2x equals 57. Divide by negative 2, and it's negative 28.5. And you might think that's bad, you can't have a negative. But if you plug it in up here, negative 28.5 times negative 2 would be a positive 57. So that's not that bad. That's a positive, yeah, so it'd be 7 plus 57. So this one does work, then that argument is still positive, so that's okay. Let's see, number 7. Yeah, number 7, we'll keep going here. 4x minus 1, it's all part of the argument, so I'm just going to use the base e to get that natural log out of there. So it would be 4x minus 1 would equal e to the third. If you want to kind of keep things exact for a while, I would add 1 to both sides and then divide by 4 to get x by itself. So x would equal e to the third plus 1, all divided by 4, which if you had to give an answer for that, 5.2714. Okay, again, you can plug that in up there. 5 times 4, that's a little over 20, minus 1 is still positive, so that's okay. And then number 8, again, this is the logarithm, so subtract 3 to the other side, and this would be 8, and then divide by 4 also, so I got the common log of x plus 2 would equal 2. The base is not written, but it's a 10, so I would take 10 to both sides. So 10 to this power, 10 to that power, I got x plus 2 equals 100, minus 2, x equals 98. If I plug that back in, 98 plus 2 is 100, which is positive, so that works. So on the whole front page, there were no extraneous solutions, so everything worked. On the back side, I'm going to kind of just pick and choose, because some of these they take a long time, and I think you kind of get the point from the ones I'm going to do here. I'm going to do 9, 11, and 12, and I think my video will probably be long enough then. But on this first one, I got a log on both sides, and that's okay. Those are actually easier, because if I use that base, if I take 5 to both those powers, now I've just got 6x minus 7 equals 8x plus 3, which is a pretty simple equation to solve. So I'm going to subtract 6x from both sides, subtract 3 from both sides. I get negative 10 equals, positive 2x divided by 2. So I got negative 5. Now, having a negative for x is not a bad thing. It's when I plug it in the argument. So if I plugged in negative 5 here, negative 5 times 6 would be negative 30 minus 7. That'd be a negative 37. You can't take 5 to any power and get negative 37, so that's an extraneous solution. So this one has no solution. I didn't even check this one because it made that one negative. Now if I plug it into this one, it's going to do the same thing, because negative 5, that'd be a negative 40 plus 3. That's still going to be a negative, so it can't happen. I'm going to jump down now, which this one here, what we're getting at, and I'm going to skip it, it makes a polynomial or a quadratic. So you'd have to get everything to one side, set it equal to 0, try to factor it, and yeah, I want to save some time. So if you approach one of those, you just got to factor it, and use quadratic formula to find the answer. Number 11. Now I've got a minus in here. So remember what we did a couple units ago with condensing. So this is where condensing is going to help us out a ton. these are both common logs. It'd be x plus 6 divided by x would equal the common log of 2. And the base that's going to help me out here is 10. So I'm going to take 10 to both those sides, powers. So I get x plus 6 over x would equal 2. You can multiply that x over if you want. So x plus 6 would equal 2x. And now subtract x. So x equals 6. And then just to double check, plug that in. So 6 plus 6 is 12. That's positive. Plug it in here. That's positive. So it works. That's a solution. So that one works. And then the last one I do for the video is number 12. Again, make sure you condense everything completely. These are both log base 3s. I'd have x squared times 9, so it'd be 9x squared would equal 4. The base that's going to help me out here is 3. So I'd have 9x squared on the left side. 3 to the 4th power is 81. And I'll go ahead and solve. So divided by 9. I got x squared equals 9. And when I square root, I'd get plus minus 3. My problem with that, if I plug in 3, it works. But if I plug in negative 3 here, that would be a negative argument. It can't work. So just positive 3 would work on that one. So be careful on those when you're solving. When you get some x squareds in there, make sure you plug them in and see if they work. So like I said, I think that's enough. I'm not going to continue on. They all kind of do the same thing. Like here you would divide to combine. The plus means multiply, so you'd have an x squared, you have a quadratic in there, so you'd have to do some factoring, quadratic formula to solve that. So hopefully that helps, and obviously I'm here today just trying to save my voice and try to get caught up on some grading. So ask me if you have questions. Don't hesitate to bother me, because you're not bothering me.